Hi friends, this is Physics Guna. Today I would like to explain the concept of polarization. In our previous classes, we have discussed that the nature of the light is wave nature that was successfully explained by interference and also the diffraction. Now, why we have to discuss this polarization? Why? Because the interference and also the diffraction explained us the nature of the light is a wave. That means the interference and diffraction is evidence for the nature of the light is wave. But actually, we know there are two types of waves, transverse waves and also the longitudinal waves. That the nature of the light is transverse wave that was explained by this concept polarization. In this polarization concept, in our today's class, we are going to be discuss what is polarization, what is polarizer, what is analyzer, what are the types of polarized lights. Okay, shall we? Yes. Okay. Polarization. Generally, if you take light, light is a electromagnetic wave. Light is a electromagnetic wave. That means in the light there is two vectors are there. So this is x-axis. If we take, it is y-axis, and this axis I am taking like this one, like z-axis. For example, if the light is traveling in along the x direction, it has two vectors. So one is electric vector and another one is magnetic vector. Another one is magnetic vector. This is a representation of the wave. Suppose if you see here, so this electric vector and this magnetic vector both are perpendicular, and also these two are perpendicular to the x-axis. That means propagation of the light. In this chapter, we are going to be understand that light consisting particles in the medium are vibrating in a transverse mode. Before understand that one, what is transverse wave? We have to know that what is transverse wave, what is longitudinal wave. In our earlier classes, we have learned that longitudinal wave and also the transverse wave. Just briefly, I would like to explain here. Okay. Okay. Yes. First of all, okay, this is the electromagnetic wave. So first of all, I would like to explain the longitudinal wave. What is that? Longitudinal wave. So what is longitudinal wave? For example, if you take a spring, normal spring, you have to be expand like that and leave it. What will happen? You can observe the vibrations. So the spring is like this. Okay, suppose if we are pulling this side and also pulling this side, and if we are leaving, what we can observe is, okay, the spring is, the energy is going like this. That means A to B, and whatever the parts of the spring is also vibrating along this direction. That means in the longitudinal wave, the vibrations of the particles, these are the vibrations. These are the vibrations. And the propagation direction of the energy, both are, how they are? Parallel. The type of waves are called as longitudinal waves. Now, come to the second one. What is that? Transverse wave. Okay, to understand that one, a small example already you have learnt. That is, just you have to take a string or a rope. A string or a rope. One end you should be fixed. That means this side I am fixed. And another end you have to be hold with your hand. You have to apply a little bit of force on it. So what we can observe? Can we observe the loops like this or not? Yes. That means whenever you are applying a little bit of force on the rope, the energy is taking transition from A to B. The energy is taking transition from, that means the disturbance is moving from this point to this point. That's why we are getting the loops. Okay. But if you see that the particles, that means the part of the wire or a rope, it is up and down motion. Is it or not? Yeah. So how it is? These two are, that means it is head represent as the direction of the energy. And it is representing that vibrations of the particle. So the vibrations of the particle is perpendicular to the energy propagation. Then the type of wave you are calling as a transverse wave. This is the introduction about the longitudinal wave and transverse wave. Now, what is that? We have to prove that the light is a electromagnetic wave. In the light, generally, if we take a sunlight or a normal light, that is unpolarized light. Why we are calling that unpolarized light? Why? Because light is a stream of particles, as we know that. When it is traveling in a medium, on that, the particles or atoms are oscillating with some amplitude. Because of these oscillations, the particles are vibrating there. These are producing the wave trains. Actually, these vibrations not only confined in a single direction. They are existing in all the directions. Okay. So, but that vibrations are in all directions, but those are perpendicular to the propagation of the light. For example, light is passing like this. Okay. On this, the stream of particles. Actually, in our polarization concept, we have to discuss about the electric vector only. Electric component only we are taking. So here, the particles are vibrating like this. Okay. For the propagation direction, so is this a perpendicular direction or not? Yeah, in any way, if you take any way, so these are all perpendicular. Okay. So we have to know about the vibrations of the particle. Okay. The first of all, to understand that one, we have to take a unpolarized light. What we have to take? Unpolarized light. Unpolarized light means normal light coming from the sun, or a tube light or light. That is a unpolarized light. Okay, as we know that if it is an unpolarized light, it has number of different directions of vibrations. But here I am not taking all the vibrations, only I am taking two vibrations. Okay, this is a plane of paper or board. The vibrations I am taking as a horizontal vibrations. So the representation of the double-ended arrow is horizontal vibration. Horizontal vibrations of the atoms. And okay, some of the atoms are executing like this. That means perpendicular to our board. Okay, suppose if I show like this, how can you observe? Is it like a dot or not? Yeah, that's way I am representing that vertical vibrations with the dot. So the dot representing that vertical vibrations. Okay, that means it is a representation of unpolarized light. The unpolarized light having different kinds of vibrations. Now we have to take a normal source of light. The normal source of light, it has vibrations like horizontal vibrations and also the vertical vibrations. So here the vertical vibrations I am denoting with double-ended arrows. Okay, so these are vertical vibrations. These are vertical vibrations. Okay, but some of the atoms are vibrating like this. Suppose front side, if you are observing, it is like a dot. That means like this. These are all we are considering as a horizontal vibrations. Okay, that means the normal source of light, sunlight, and light coming from the tube light, these are all, okay, unpolarized light. This is the representation of the unpolarized light. Once again, I am telling, for example, if the light is passing like this, the light is passing like this. So in this light, whatever the particles are there, atoms, these are vibrating like this. Okay, so how they are vibrating? Like this and like this. In all the directions they are vibrating. Our aim is to be prove that these vibrations are the vibrations of the particles are perpendicular to the propagation direction of the light. That's why here we have taken the unpolarized light. It has two vibrations. Now we are allowing them through the slit. This is one slit and this is another slit. This is another slit. These slits are parallel to the vertical vibrations. These two slits are parallel to the vertical vibrations. This slit I am calling as a and another one I am calling as a B. Now the light is passing like this. So here the vibrations are in so many directions, but here we are considering only the vertical vibrations and also the horizontal vibrations. Then this slit which can allow which type of vibrations? Is it horizontal vibrations or vertical vibrations? Yes. For example, the slit is like this. Light is passing like this. Light is passing like this. Okay, perpendicular to your board. So the vibrations of the particles are in all the directions. Suppose if I am allowing this one, this type of vibrations, will it allow? No. So the vibrations which are parallel to that slit, only it is allowing. Okay, that means here we can get only the vertical vibrations only. Only the vertical vibrations only. So this one also vertical, because of that one, it will also allows only the vertical vibrations. Now, in the output, the vibrations of the particles are confined or belongs to how many dimensions? Only one dimension. Then this is called as polarized light. This light is called as a polarized light. Who is producing that? So this slit is producing. That's why it is called as a polarizer. Okay. And the process of converting of unpolarized light into polarized light, that is called as a polarization. Okay. Now we have doubt. What is our doubt? Whether it is allowing only the vertical vibrations or if it is allowing the horizontal vibrations. Because of that one, what you are doing is you are rotating the second slit. You are rotating the second slit. Okay, actually how the slit is there like this. Okay, from the first slit the vibrations are coming like this. You are taking another slit. Now you are rotating this one. Actually the vibrations are coming like this, but your slit is like this. Both are mutually perpendicular. That time you didn't get any intensity there. If you are getting that zero intensity, that is called plain polarized light. That means what is the work of this one? So what is the work of this one is, sorry, okay, this one is a analyzing. It is analyzing. What it is analyzing? Whether the polarizer is producing a perfectly plane polarized light or not. That is analyzing. That's why it is called as a analyzer. Okay. So based on these vibrations, we are classifying that the polarizer light is three different kinds. That is plane polarizer light and circularly plane polarizer light and also elliptical polarized light. Now I am going to be explained in detail. Okay, so types of polarized light. Types of polarized light. How many types? Three types. One is plane polarized light. Sorry. Okay, plane polarized light. Second one is circular polarized light, and the third one is elliptical polarized light. Okay, now we will discuss in detail. For example, as we discussed that if it is a light is passing through this like this. Okay, it has the two vibrations, that is horizontal vibrations and also the vertical vibrations. Okay, that means in a normal source of light, it has the vibrations of the atoms are in all the directions. For example, if we are allowing that one through the slit, vertical slit, we will get only the vertical vibrations. That means if the vibrations of the particles are on a plane, then that is called as a plane polarized light, or it is also called as linearly polarized light. Linear polarized light. Okay. So here the vibrations of the particles always they won't be vibrate like up and down motion or a to and fro motion. Okay, the up and down motion vibrations we are calling as a vertical vibrations. The to and fro motion of your particles, so we are observing like a dot. That's the horizontal vibrations. Okay, but sometimes the electric vector of the light is rotating around the propagation of the light wave with a constant amplitude. Just you have to observe. This is the propagation of the light. That means the light is passing towards you. In this, the electric vector is having some amplitude like this. Now, actually in the previous case, they are vibrating like this. Now, those are not vibrating. Those are rotating. Those are rotating with a constant amplitude. That means it is a maximum displacement is called as a amplitude. Now from that one, it is rotating with a constant amplitude. So that means if you see that the light is perpendicular to the board or a plane of paper, okay, perpendicular to the paper, okay, like this. Now the electric vector is having some amplitude. With that amplitude, it is rotating like this. What is the shape? Yeah, the shape is circle. The shape is circle. The type of polarized light is called as circular polarized light. Okay. For example, if light is passing like that, okay, from this, so with a constant amplitude, it is going like a helical path. It is like a helical path. Now, if it is in a clockwise direction, okay, if it is clockwise direction, we can say that is right circularly plane polarized light. Okay, I am not writing it fully. Right circularly polarized light. For example, the light is passing like this. For that one, the vibrations are, the rotations of the particle is like this. with constant amplitude. That means if that rotation of the electric vector is anti-clockwise, then we can say that that is left circularly polarized light. What is that? Left circularly polarized light. That is second one. Now come to the third one. Elliptical means in the first case the vibrations are either maybe the up and down or to and fro. Up and down or to and fro. They are belongs to only one plane. That's why that is plane polarized light. In the second case, the electric vector is rotating with a constant amplitude around the propagation direction of the wave. Okay. Now, in the third case, elliptical means, so in one direction, the amplitude is maximum. While the electric vector is rotating around the propagation direction, in one direction, the amplitude is maximum. And when come to the horizontal, that is minimum. Once again, if it is come to the, what is that, vertical maximum. And once again, it is come to the horizontal minimum. So, like this. For example, if you take here, if it is a light, okay, so around this light, around this propagation direction, the electric vectors are rotating. So while they are executing, so in one side, so that means as a vertical, if it is traveling more distance, it has maximum amplitude, and it is rotating like this, that time it has minimum amplitude. This is minimum amplitude and this is maximum amplitude. Okay, so like this, like this, like this, like this. Okay, so that means suppose if the light is propagating like this, in one direction it has maximum amplitude, in another direction it is less. So in one direction maximum. Okay, so then the type of polarized light is called as elliptically plane polarized light. We can understand this circularly plane polarized light and also the elliptically polarized light by using the slink. Okay, slink. If you take the slink, suppose if you are pressing like this, you can observe the vibrations. Suppose if you see that the slink is like a helical path. Helical path. That means that is a particular, that means circle. Suppose if you are pressing in a one direction, what is the shape of the slink? Is it a elliptical shape or not? Yes. So like that we can understand that types of polarized light. Okay. For our next class, we will discuss some more. If you like this, please give me a like and please subscribe my channel. Thank you.